Well, hi, I'm Brennan Spiegel. I'm a gastroenterologist here at Cedars-Sinai and Director of Health Services Research for our health system. And today I'm going to give you a brief overview on some of the exciting and fascinating updates in the use of artificial intelligence in gastroenterology. So this is a big topic. Why don't we get started here? I'm going to pull up my slides right now and start off with my cover slide. I have no specific conflicts of interest as it pertains to artificial intelligence. Now, we now know that artificial intelligence is crashing upon our shores. You've probably seen ChatGPT. I'll come back to that. And we're figuring out how do we combine the human brain and all of its innate capabilities with computers. And in some cases, computers can easily outthink us. In other instances, computers are virtually useless right now. And so a term that's starting to evolve, rather than thinking of all of this as artificial intelligence, is augmented intelligence. That's the other AI. Can we augment our natural abilities as humans and the consciousness that we bring to the world with machines? And where is that interface in medicine and in gastroenterology in particular? And that's what I'm going to talk about today. So let's start with some basic definitions. What is artificial intelligence? Well, here's sort of the Webster textbook definition. It's simply a branch of computer science dealing with the simulation of intelligent behavior in computers. It's also the capability of a machine to imitate intelligent human behavior. You may have heard of the Turing test, which was put forward by Alan Turing, which was a test to see if a human can tell the difference between another human and a computer when faced with the same sort of set of conversations or interactions. And we're starting to see computers that can pretty easily pass the Turing test and imitate intelligent human behavior. Now, artificial intelligence has many different components. We're not going to go into a lot of detail today. I'm going to spend most of our time talking about natural language processing and image recognition, which is particularly important in gastroenterology. But I just want to emphasize that there are many different branches: machine learning, NLP, vision and speech systems. And within those, there are even finer distinctions that we're not going to go into today, which is more of a largely clinical talk rather than an overview of AI. But I just want to be complete in showing you the extent of what AI is now considered to be and the different methods involved. So let's talk a little bit about natural language processing, which is one area where AI has really shown incredible capabilities. And, we heard about this years ago when the Jeopardy champion here went up against, at the time, the IBM Watson computer, which has now really been eclipsed. And this was an amazing moment for artificial intelligence.
What's a legal ease for 1200?
Watson.
What is executor?
Right.
Same category, 1600.
Answer, very double.
There are the developers, very excited to see
when I knew
Watson
it's
getting
over.
the double Jeopardy question. And it was at that moment that he knew he was going to lose to this computer. So that was a big moment, sort of in the public perception of AI. Other examples are, chess grandmasters like Garry Kasparov, being defeated by Deep Blue, and computers being able to do amazing work on a chessboard, for example. Now, machine learning is another really important area, and we've been hearing a lot about that with regards to driverless cars and automated driving. And of course, Tesla's made a lot of inroads, although continues to struggle with obtaining, human-like driving capabilities. This is Waymo that's been working on a form of automated driving for many years. I routinely, as recently as yesterday, see this vehicle driving around Los Angeles. They are constantly testing out their systems extensively. But this is a video
Not all the car's
a couple
actions
years
are
ago.
that smooth, though. This car is approaching an accident. Look at all the human drivers pulling to the left, using their turn signals. They can see the lights from a long ways away, the emergency lights in that intersection. They know they can't go straight through the intersection. They're all merging left, cutting into the line, probably looking each other in the eye. The Waymo decides now it's going to cut in the line way ahead of about 50 people. It appears that the driver took over and moved off to the right. So just a really robotic looking decision.
So a really good example of the difference between humans and computers. Here's this unusual sort of situation. All the humans know instinctively what to do. The computer thinks it's just going to cut everybody off, and that's just not going to fly. Now, this is an even more concerning situation that occurred a few years ago with this woman who just struck this passenger. I'm sorry, this woman who was in the passenger seat, I should say, was not paying attention in the driverless vehicle, then all of a sudden strikes a pedestrian. And you can see the moment that she looks up and sees that she's actually striking this pedestrian who tragically died. So, AI is here, but it's not completely here yet. Now, vision systems have been particularly advanced, particularly in medicine. And this really got its start with dermatology, which makes sense. Looking at the surface of skin can send photographs to your dermatologist. They can make a diagnosis often just by looking at the image. But what if we can use a computer to classify skin cancer using, in this case, deep neural networks? And what you're looking at here is a series of receiver operator characteristic curves, or ROC curves. You'll recall that the area under the curve of 1.0 is a perfectly accurate test. And here what they did is they classified images by expert clinicians and then trained the computer. And they found that the AAC for cancer, melanoma, and so on was extremely high, with an AUC in the 0.94 plus range, extremely accurate. Now, of course, computers can get fooled. This is a classic image of puppy dogs and fried chicken. They look suspiciously similar, and computer can sometimes be challenged in distinguishing these kinds of things. Or here are dogs and blueberry muffins, which also look shockingly similar, but humans can immediately tell them apart. Computers can struggle. So we still have a lot of work to do there. This book by Eric Topol called Deep Medicine: How Artificial Intelligence Can Make Healthcare Human Again really talks about the limitations of computers, but also the opportunities, ironically, to use computers to allow us to actually increase the humanity in healthcare, possibly by giving doctors more time to do the things that humans do best, like consulting with patients and conducting shared decision-making and empathizing and understanding the emotional components of healthcare. And so in this, there's a table here of the so-called outlandish expectations for artificial intelligence in healthcare, a partial list. It's going to outperform all doctors. It's going to diagnose the undiagnosable, treat the untreatable. We're hearing a little bit more of this these days, and this book's several years old now. But we are not going to lose our jobs to computers in general if we figure out how to continue to evolve as doctors. The doctors that don't use artificial intelligence might end up getting replaced faster than those who do. And that's a theme that comes up frequently, and why we're talking about this in this conference. Now, ChatGPT came out in just recently in November, and you may have seen this. It's pretty incredible. So I just literally typed it into it. I'm giving a talk about the use of AI in gastroenterology. What should I discuss? That's a question I just posed to ChatGPT, and you can see how quickly it starts to answer the question. The use of AI in GI has been rapidly evolving, and here are some ideas. You might want to talk about automated polyp detection and AI systems being trained to detect polyps in colonoscopy images, diagnostic support to help diagnose IBD or celiac or IBS, as I'll show you today, risk prediction for various conditions like predicting colon cancer risk or Barrett's esophagus risk, personalized medicine using AI to predict how patients will respond to different treatments, image analysis to look at endoscopy images or capsule endoscopy images. Okay, so the computer has already written my talk for me. There are many exciting developments in the use of AI in GI. Your talk could focus on any of these topics. So there you go. So let's get started here with that introduction, talking about endodermatology. We think of GI in a way as like dermatology, but we're looking at the inside. So we know that AI has been very effective in exodermatology. What about endodermatology? So we always spend time looking at these lumps and bumps and figuring out which ones are concerning and which ones maybe not so. And just think about all the opportunities for computers to help assist gastroenterologists in evaluating in real time those images. This is an article published in the Red Journal a couple of years ago, looking at the promises and the pitfalls of AI in endoscopy. And so there's been a lot of efforts to use AI to characterize the surface features of polyps and estimate a probability of it being a tubular adenoma or anything else to help us decide whether to even remove it, although I think we're going to, for the most part, remove these, whether maybe we can discard them without sending them to pathology if the computer is so sure that something is, let's say, a hyperplastic polyp. These are open questions. So there are many opportunities for GI with endodermatology, Barrett's esophagus, gastric cancer, small bowel ulcers, colon polyps, IBD, even IBS, as I'll show you in a second. So I'm going to talk about a few of these today. Starting with the top, looking for Barrett's esophagus associated neoplasia using wide area transepithelial sampling and AI programs. So a computer can actually look at the histopathology and quickly identify suspicious histopathology. And in this randomized trial, in which there is AI-assisted review of the histopath, it increased the diagnosis of high-grade dysplasia and cancer by over 14%. That's really quite remarkable and something we need to be thinking about to support our pathologists. This is a study using convolutional neural networks to diagnose the invasion depth of gastric cancer. Again, using images based on conventional endoscopy in this case, quite sophisticated AI. And once again, looking at the area under the curve, comparing to, let's say, experienced endoscopists or junior endoscopists, computer did pretty much just as well as the experienced endoscopist in estimating the depth of penetration based upon the surface features. So again, really important opportunities for clinical gastroenterology with a very high AUC. What about for detecting early gastric cancer? This is a study that evaluated AI for early gastric cancer. And the study looks at a number of outcomes, but I just want to highlight some of the key features in this text here. As it says here, there remains considerable selection bias amongst the images that have been used. So this is an opportunity to improve outcomes. And in addition, it says that only high quality images were selected. Performance may suffer when the software is confronted with the varying image quality and distractors that endoscopists routinely encounter in real life. So this is just pointing out that we need to think about these caveats before we go hook, line, and sinker with all of these studies. There are really some issues that need to be addressed, and they propose some steps to really help improve some of the research here. The first is to use real-world quality images rather than highly selected images, and also to do prospective evaluation. So we need to do more of that. Now, another area that has achieved some interest is using automated detection of erosions and ulcerations with wireless capsule endoscopy. Again, using this deep convolutional neural network approach. Again, using surface imaging in this study, the capsule can look at all sorts of interesting features. And once again, has a very high AUC in terms of predicting evidence of ulcers and erosions. And that can be a big deal if somebody's on NSAIDs or has surreptitious bleeding. And we've got, 50,000 images to go through. Wouldn't it be nice if the computer can really do the work for us? And so this is an example showing that that can be achieved with a very high AUC. Another study here showing the same thing. Now, what about using AI to identify histologic inflammation in the setting of ulcerative colitis? This is another study where they used an endocytoscope to help look for evidence of ulcerative colitis using artificial intelligence to distinguish active from healing ulcerative colitis. And so the endocytoscope here, it has this camera that presses right into the mucosa and creates these beautiful images. You can see on the right, it almost looks like an actual histopathologic specimen. And using this approach, which has been around for a long time, but augmenting it with artificial intelligence, these investigators found a pretty high sensitivity and specificity and very high positive negative predictive value and accuracy for diagnosing or distinguishing active inflammation versus non-active. Now here, we're going to turn our attention to the use of artificial intelligence in colonoscopy. And so there's been a lot of very fascinating work being done here. Some of you may have used this system before in your own practice, a system that will put a box around polyps in real time. Now, as I look at these polyps, I feel like I would have seen them, but some of the smaller ones you can sort of miss. Obviously, there can be false negatives, false positives, true negatives, true positives, 2x2 table. But the idea is this is pretty unobtrusive and can help quickly identify lesions as we're doing the procedure. And so in this study, this was a study finding real-time 96% accuracy during screening colonoscopy in identifying polyps. And this was a randomized prospective trial to see whether use of this system can improve the yield of endoscopy or colonoscopy. And importantly, what they did find is a higher adenoma detection rate of 29% in the AI-supported colonoscopy versus only 20%. Now, both of these are pretty low, so one questions if more experienced endoscopists perhaps would find quite as big of a delta, but nonetheless, in this randomized trial, they did find a difference, including the mean number of adenomas detected overall. Now, this is another study looking at predictions of findings at screening colonoscopy using a machine learning algorithm based on complete blood count. So this is a machine learning algorithm out of Israel that simply looks at the CBC through the electronic health record, just pulls up the CBC and all of its components, including the differential, and from that can put an estimate on whether there might be colon cancer. This is a pretty incredible, potentially high yield way to screen for colon cancer. You can imagine there might be false negatives, false positives, but they did find some accuracy compared to colonoscopy. So we don't even need to just rely on colonoscopic image analysis, but also on other types of data available to us. And this is a sort of review looking at AI for the determination and management strategy for diminutive colorectal polyps, HOPE, HOPE, or HELP. And this is a study that suggests that we could use this to support a resect and discard strategy. In other words, if the imaging at the time of polypectomy can reliably distinguish whether a lesion needs histopathologic review or not, that would be really helpful. And if you look down here, there's a 97% negative predictive value, meaning that if the AI said there was no problem, you could pretty much assume there's no problem and potentially just discard and save a lot of money. Now, this was an interesting study looking at interventional endoscopy and seeing if AI could be used to reduce radiation exposure. So they use an AI system to decide when radiation should be used or not based upon the images that are on the screen. And they were able to demonstrate a significant reduction in radiation exposure to both patients and providers in the use of AI for this interesting application. Now, I'm just about done, but I want to point out, I just over the weekend saw this tweet that came from Kewin Sia, who's on Twitter, and he just pointed out this new study that is using colonoscopy with AI to diagnose IBS. And that's quite interesting because we usually think IBS has a normal colonoscopy. Well, that's not necessarily true. There's been some research going back several years that some patients with IBS may have erythematous patches, maybe they have an increased risk of diverticulosis, for example, but they used a computer to distinguish, and with a high degree of accuracy, with an area under the curve of 0.95, could distinguish IBS versus no IBS. And so that seems really interesting. But then there's certain sort of, key opinion leaders that sort of weigh in. This is Alex Ford from the UK, who says, well, given that we should not even be performing colonoscopies in people with IBS, this seems like a pointless exercise. Well, I don't know if it's pointless. I honestly feel that's short-sighted because, yes, we're not suggesting, no one's suggesting right now that we should be doing colonoscopies in people with IBS. This is a research study. But isn't it interesting if it's true that there might actually be abnormalities that are otherwise imperceptible to human eyes? And if so, what is the biological consequences of that? What can we learn about the biology of IBS, for example, if it turns out there are interesting differences that a computer can identify? And maybe we don't need to do a colonoscopy in everyone, but maybe we can simply do a flex sig in the office and quickly diagnose IBS and avoid a whole bunch of future tests. The point is that no one's going to change how we do, IBS workup right now, but that shouldn't hold us back from thinking creatively about using AI to hopefully rigorously distinguish among different conditions. So I think whenever you hear that this is pointless or this is useless, you got to think about the technology adoption life cycle. We're very early in AI, and there's certain innovators that will put forward ideas, and then there's sort of a chasm. You need to have a certain number of innovators using something before early adopters get on board, then the early majority, the late majority, and the so-called laggards who really kind of ossified, want to keep the status quo. Honestly, I think this is about how open are you to new ideas. If you're not real open to new ideas, you'll say something like that last study was just, quote, pointless and of no use at all. I think that's really short-sighted, to be honest. All right, well, we have many challenges. We need more prospective validation studies. We need to demonstrate the impact on patient outcomes. We need to evaluate whether it's cost-effective, study how to implement this into routine workflow. And these are all things that are not yet clear. Some use cases are more advanced than others. I will say that I recently posed a series of questions from the GI board exam based upon our books that we've written, these Acing the GI board books, to ChatGPT. And well, it definitely struggled with some of the questions, but did really well on others. And so we're doing a study now comparing it to humans. So if you guys are willing to take an anonymous quiz, I'm going to actually distribute that on my Twitter account, and you can go in and take the quiz. We're going to see how you do compared to the computer. It's anonymous, so no one's going to know how you did. Just don't look up the answers. We want to see how the computer compares to the humans. I actually subjected ChatGPT to that quiz. It really didn't do great, so I asked it to draw an oil painting of itself struggling through a medical board exam, and it actually drew this depiction on the right of itself taking the test, which I find absolutely fascinating that it can draw a picture like that. All right, I'm going to end there. Thank you very much. I hope this was a useful, albeit brief, overview of artificial intelligence in general and for gastroenterology. A lot more to come. We'll be hearing incredible updates over the next year and beyond, and stay tuned to this space. Thanks so much.